We are going to be looking at some examples that I took from the textbook to show you how to make ketones and aldehydes. In first example, what I'm trying to do is to make a ketone from formaldehyde. And to make a ketone from formaldehyde, you need to have a Grignard reagent. So here I'm using Grignard reagent that is made by cyclohexyl bromide and magnesium and ether. So this is my Grignard reagent. Now, since I'm going to use the Grignard reagent to make a ketone, I need to pick an aldehyde. And if you look at the product, in the product I have 3 carbons that I'm attaching to this ring. So I need to get an aldehyde that has 3 carbons in it. So when I use this Grignard reagent and its aldehyde, and I'm going to, then after I acidify it, we will be getting a secondary alcohol, if you remember from the lecture. Then when the secondary alcohol is formed, all I need to do is to use an oxidizing agent to change it to a ketone. An oxidizing agent could be anything because this is a secondary alcohol. Here I'm doing the same thing, but in this example I picked a ketone that has aromatic ring. Since your ketone has aromatic ring, you have more than one choice. You know, if you have, you can do it the same way as we did there, meaning you can change this, you know, benzyl bromide to, you know, Grignard reagent, then pick your aldehyde like we did before, 3 carbon long. We pick an aldehyde with 3 carbons, then we get the secondary alcohol, and then when the secondary alcohol is formed, we need to oxidize it to get the ketone. The other choice is to use what we learned in chapter 17. In chapter 17, we learned that we can use acid chloride to do, you know, Friedel-Crafts acylation. And to do the Friedel-Crafts acylation, then you need acid chloride that has 3 carbons in it, and you need the Lewis acid. So that's for step number 1. Then for step number 2, you add water, or you could acidify the solution to get the ketone. In example 3, we are looking at how really to use carboxylic acid to make a ketone. And if you remember from the previous video where we talked about this in a lecture video, we learned that in order to make a ketone from carboxylic acid, we need to first remove that hydrogen. And in order to remove that hydrogen, we have choice. We can use lithium hydroxide, or we can use alkyl lithium that we are going to be using to make the ketone. Like in this case, this is the group that I'm going to add to carboxylic acid. So all I need to do is to use 2 moles of this in my solution. And so regardless of which one I use, the first step is always to remove that acidic hydrogen to get this carboxylate ion. When the carboxylate ion is formed, then the other mole of your alkyl lithium is going to play a role, and in here the second alkyl lithium is going to attack that carbonyl carbon and to give you this dianion. And when the dianion is formed, then when it is acidified, you get this hydrate. And when the hydrate is formed, it's unstable, it loses water molecule to change to ketone. So this is how you would make ketone, this ketone in here from carboxylic acid. In this example, we are looking at how to make a ketone from nitriles. Here is a nitrile. And in order to change a nitrile to a ketone, we need to use the Grignard reagent first. So this is the Grignard reagent that I'm using. When I use the Grignard reagent is going to attack that carbon that is attached to nitrogen. And then when we acidify it, we get what is known as imine. And imine, like I said in the previous video, are compounds with carbon and nitrogen doubly bonded. When imine is formed, then it's going to be acid hydrolyzed, or it needs to be acid hydrolyzed. Then when it is acid hydrolyzed, you get that product that we wanted. And if you notice, we went from nitrile to a ketone. All right. Now, You also can use nitrile to make aldehyde, and to do that you are going to do reduction, and the reduction you want to do is use weak reducing agent. You are not going to be using lithium aluminum hydride, because lithium aluminum hydride, as you know, is very strong reducing agent. So when the aldehyde is formed in the solution, then eventually it's going to change to an alcohol. So if you are going to stop the reaction right there, what you need to do is to use modified reducing agent, and that modified reducing agent, as is mentioned in your textbook, is diisobutyl aluminum hydride. So you add this reagent first, then you add, you acidify the solution, then it's going to be changed to aldehyde. In this example, we are learning how to use really a nitrile, okay, to make ketone, all right? And again, this is one way to do it. There are always more than one way. Like, in here, I need to change this to a nitrile. So the first thing I would do is to treat it with sodium nitrite, sodium cyanide, sorry. And when sodium cyanide is formed, I would react that sodium cyanide with, Grignard reagent. And when the Grignard reagent is, used, we get this imine. This is something that we did earlier right there. And then when the imine is formed, I need to acidify it. Then when it is acidified, I'm going to get a ketone. And that ketone would be my major product, and that ammonium ion would be the minor product. That's one way to do it. If you don't want to use a nitrile, then you can use what you learned before. You can treat your alkyl halide. Here is benzyl bromide with magnesium and ether first to make a Grignard reagent. Then pick the aldehyde like we did before. And when you pick the aldehyde, then you need to acidify it. Then when it's acidified, you're going to get alcohol. When the alcohol is oxidized, then you're going to get ketone. Okay, and we also can make ketones, aldehydes, using acid chloride. And in here we are using an acid chloride to change it to an aldehyde. Okay, and to use acid chloride to change to the aldehyde, you want to be careful again. You want to reduce this. To reduce this, you could use the reducing agent. But if you use a strong reducing agent, like we said not to use previously, this would change acid chloride to primary alcohol. Now, in order to avoid this, we can use a mild reducing agent, like the book mentions, lithium aluminum, tributyl aluminum hydride. We could use that, or we also could use what we used earlier in another example, which was this one in here. We can use that one too. And when we use either of them, then the reduction is going to stop where the aldehyde forms. In this example, we are using acid chloride. Okay, in this example, we are using acid chloride to make a ketone, right? So if you are going to use acid chloride to make a ketone, you are not really doing reduction. All you are doing is treating acid chloride what is known as Gilman reagent. And as you can see, this is di-alkyl, whatever. What it could be alkyl, it could be phenyl, it could be other type of R groups. So that's what you use. So when you use Gilman reagent, which is known as lithium dialkyl cuprate, then acid chloride is going to be changed to ketone.